Welcome to this explainer. Today, we are unpacking a massive paradigm shift in artificial intelligence. We're talking about a single 2017 research paper called Attention is All You Need, that quite literally birthed the modern AI boom. Now don't worry, we aren't going to get bogged down in deep mathematics today. Instead, let's discover how this specific breakthrough translates directly into real performance, cost savings, and efficiency for your business. Think about this for a second. Imagine having an employee who can only read a financial report one single word at a time, strictly left to right. And by the time they reach the 10th page, they've pretty much completely forgotten what was on the first. Well, that was basically the state of AI. But what if a system could absorb the entire context of that report in a single glance? That is the exact question that drove researchers to abandon the old rules of machine learning and create a completely new, vastly more efficient model. So here is our roadmap for today. We'll start with the sequential bottleneck, then cover the self-attention breakthrough, take a look inside the transformer model, review its unprecedented performance and efficiency, and finally, wrap up with key takeaways for executives. All right, Section 1, the sequential bottleneck. Let's look at the limits of old AI. Before this breakthrough, the industry standard for sequence tasks relied on recurrent neural networks, or RNNs. But they suffered from a really fundamental flaw called the sequential bottleneck. Data had to be processed just one step at a time. You feed in word 1, then word 2, then word 3. In a business context, it's kind of like having a massive factory full of eager workers, but your assembly line forces everyone to stand around waiting while only one single person works at a time. It drastically slowed down training and placed severe constraints on memory. The transformer changes that paradigm completely by shifting to parallel processing. It's fast, it's highly contextual, and it lets all your metaphorical workers operate simultaneously. Moving on to Section 2. The self-attention breakthrough, seeing the whole picture at once. So instead of reading a sequence word by word like that old RNN, self-attention allows the model to act like an entire page scanner. It maps how every single word relates to every other word in the sequence completely simultaneously, regardless of how far apart they actually are. In executive terms, it's not looking at data in a silo anymore. It's instantly computing the global context of the information you feed it. Let's break down how this actually works. Take a sentence that has the word making in it. It's really fascinating because the AI instantly connects that word with other words like more and difficult much further down the sentence. It resolves this dependency, knowing that the phrase is about making something more difficult without having to wait for all the sequential steps between those words. It just instantly draws that connection. And honestly, it gets even better. The model actually uses what the researchers call multi-head attention. You can think of it like a highly efficient corporate team of specialized readers working in perfect parallel. One head of attention might focus entirely on the grammar of the sentence. Another head might be looking for emotional tone, while a third is tracking the main subject of the paragraph. By processing these different representations at the exact same time, the model achieves incredibly deep understanding in a fraction of the time. Section 3. Inside the transformer model. Streamlining AI architecture. Now, the architecture diagram itself might look incredibly dense at first glance, but the crucial point here is actually what's missing. If we look closely at how the model is built, there are absolutely no recurrent loops. That old sequential bottleneck is totally gone. Data travels in a straight, unobstructed shot from the bottom up. By relying entirely on the self-attention mechanisms we just discussed and dropping recurrence completely, the architecture becomes a streamlined, highly parallelizable powerhouse. Which brings us to Section 4. Unprecedented performance and efficiency. Let's talk about the ROI of the transformer. So, what does all this parallel freedom actually mean for your bottom line? Well, it means this: 3.5 days. The researchers trained their transformer model on a massive data set and established a brand new industry-wide accuracy record in just 3.5 days, using 8 standard GPUs. That is a mere fraction of the weeks or even months required by previous legacy models just to achieve lesser results. Faster training means drastically reduced time to actually deploy AI solutions in your enterprise. And hey, time is money, right? When we compare the computational training costs, which is measured in flops or floating point operations, the difference is just staggering. The previous state-of-the-art models required towering amounts of compute power, but the transformer achieves superior accuracy with a massive drop in compute. And in the business world, compute power equals your cloud provider bill. So the transformer architecture doesn't just make AI smarter, it makes training it significantly cheaper. Finally, Section 5, key takeaways for executives, the foundation of future AI. Looking at the big picture, this research didn't just solve a simple translation problem. First off, it eliminates sequential friction by ditching those slow RNNs entirely. Second, it relies on self-attention for instant parallel context mapping, letting the AI see the whole document at once. Third, because of this, it achieves superior state-of-the-art accuracy. Fourth, it does all of this while massively reducing training time and compute costs, dramatically improving your AI ROI. And finally, which is absolutely vital for business applications, the researchers proved it generalizes well to other AI tasks, like parsing English sentence structure, even when it has limited data to work with. It's just a highly flexible, highly efficient cognitive engine. I'm going to leave you with this final thought. If AI no longer has to read word by word, if it can instantly comprehend entire datasets faster and cheaper than ever before, what unprecedented possibilities open up for your business? How will attention-based AI disrupt the bottlenecks in your specific industry? Thank you for joining me for this explainer, and I highly encourage you to look at where the transformer architecture can fit into your own digital strategy.